This evening is Dr. Al Crissman, who has been in the electrical engineering department at Grove City College for many, many years. He has written many articles for QEX, for QST, and other periodicals. He may be most famous as the advisor for W3CDG, and just kidding. But Al has been a very steady voice for amateur radio and has furthered the art and research when it comes to antennas. Please give a nice warm welcome to Al Crissman, K3LC from Grove City College. And with that, Al, we're going to turn it over to you and let you have you can share your screen and teach us something here that we can be fascinated with.
Okay, Tim, thank you so much. And I'm looking here, there we go. Thank you for having me here this evening. Let's see if I can make this bigger. This evening, I wanted to talk about an article that Joe Johnson and I had written some time ago. I was hoping that Joe could make it. I invited him to come and join us. I don't know how familiar you are with the south central part of the country. I grew up in Chambersburg down in Franklin County, which is on the southern border of Pennsylvania, just north of Hagerstown, Maryland. The county to the east is where Gettysburg is located. That's Adams County. So from my house over to Gettysburg, you just go up over the mountain on the Lincoln Highway, US 30. Joe is retired from the FCC. He actually lived on the same road as the FCC licensing offices there, just west of Gettysburg. If you ever, in days gone by, renewed your license by sending off to Gettysburg, he actually lives near there. He worked for the FCC as an engineer, but he worked out of their Washington, D.C. office. If my memory is right, his wife actually worked at the FCC office there in Gettysburg. So anyhow, Joe is retired and very active in ham radio, not able to climb towers anymore, but he lives on a hillside just west of Gettysburg. He lives on like the southeast corner of the hillside. And so he's got a magnificent shot into Europe to the northeast. The hill is to the northwest, but in other directions, he has really nice views in those other three directions. So he can have very good antennas set up. Several years ago, he contacted me about a design for the 75-meter band. I was talking to him on the phone a couple of weeks ago, and he said he's the kind of guy that likes to get on one band and work it to the max, and then when he's done everything he wants to do, he switches to another band. And so apparently now he's moved on from 75 meters, and he's been putting up wire beams for the 20-meter band. But tonight, I want to talk about this particular article. It was in QST. You can see a 3-element Moxon-style vertical Yagi for the 75-meter band. And the picture there, you can see off to the right edge is his tower that he used to support the antenna. This is basically this tower is a full-size 160-meter vertical radiator. It's 140 feet tall, insulated at the base, and has I believe it's 60 full-size radios for 160. We'll look at it in a moment. And what he has done is put some wire elements on each side of it, one to the northeast, one to the southwest, and then put relays in it, so switch them from either being reflectors or directors, so he can fire either northeast or southwest. Notice there the design frequency is 3790, so this was set up for operation on the phone band. The last I spoke with him, he had over 300 of DX countries worked on that band, and so it was about time for him to move on. Now, his Yagi actually had just 2 parasitic elements, but with the computer we were able to design it so that we can use 4 and beam in all 4 directions. So here's a drawing that Joe made. There's 140 feet of Roan 25, base insulator, 60 radials, each 130 feet long. I believe they're buried about 4 inches deep. And then on the left here, you can see a parasitic element, and it looks kind of like a Moxon. It's mostly vertical, but it's bent at the top, 15 feet of the top, and then there's some rope that holds it to the tower. And then at the bottom, we've got either 15 feet when the element is working as a reflector, as a director, and then there's a vacuum relay. We switch in another 8 feet to make it function as a reflector. And then the same thing on the other side. So it's symmetrical. Got 2 of these wire elements that can be switched to either be longer or shorter to be reflectors or directors. Notice the spacing is 43 feet. The height of the vertical part is 90 feet. So it's definitely big. My backyard is about 50 by 50, so it's not going to fit. Now here is a model that I made with EasyNet to do some simulations on the initial antenna. There we can see the tower. There we have the 2 parasitic wire elements. This one on the left has reflector, and this one has director. And there's the ground screen. So that's what it looks like in my computer model. And I used EasyNet. I used the version that allows you to actually put radials in the ground. So it takes a lot longer for the program to run when you include radials buried in the soil. Now let's scroll down here. Here are some pictures that he took. The tower looks like it's tilted, but it's not. It was the camera that's tilted. And here he's enhanced the photos to show that there's the director, and there we are firing to the northeast. And as I mentioned, if you were at his house standing at the base of the tower, you could look to the northeast and you'd see a long, shallow valley that goes out toward the northeast for a long way. So he's got a great foreground to the northeast into Europe. And there's the vacuum relay box that he can use to switch from reflector to director. Now here's a picture of the other side. Again, he's darkened in the reflector element, and looking off to the right would be to the southwest. There's another tower in the background there. Now here's a result from EasyNet, from the modeling on the computer. Peak gain, a little over 5.7 dBi. Notice one of the nice things about it is the takeoff angle is only 15 degrees. The front to back is about 14 dB. There's this kind of large lobe here, which isn't too nice, but otherwise we've got a really good radiation pattern at a low takeoff angle. In a little bit, I'll compare this with what we get from a typical 4-square, and we'll see the pluses and the minuses of the half-wave tall element versus the typical 4-square that has quarter-wave tall elements. Notice the input impedance here, where the tower is about a half-wave long, so we've got a pretty big real part and then a lot of reactance. Fortunately, with an L network at the base of the tower, you can tune that to 50 ohms. Now here's the azimuth pattern, and of course we'd like to have a beam width of 90 degrees or more, so we can just switch in 4 directions. Notice that's what we've got. Here's straight north, east is to the right, and these lines here, these purple lines show us the half power beam width. So it's over 90 degrees. So we get nice coverage in 4 quadrants. Here's the half power beam width, almost 102 degrees. Notice that our design frequency 3790, just below the 3795 frequency in the DX foam band. Now, as I mentioned, let's compare that with a 4-square. So the red trace here is the vertical Moxon-Yagi with half-wave elements. And here, this big blue trace is the typical 4-square over a good ground screen. Notice this right here, this tick mark is 15 degrees takeoff angle. And you can see there's the crossover point. It's almost exactly at 15 degrees. Above 15 degrees takeoff angle, your classical 4-square does better. It's got a lot more gain up here at the higher takeoff angles. But everywhere below 15 degrees, if you really want to work long DX, this half-wave element, notice it suppresses the angle, the high angle radiation here, but the radiation it takes from the high angles, we get down here at lower angles. So in the back, the lobes are more or less similar. This one, the half-wave antenna, is a little more irregular, but they both do a pretty good job on the back. I'll scroll down here a little further. We can see the numbers. The 4-square has more gain. Notice the peak gain is about 6 1/3 dBi versus 5.7. So we're looking at a little more than half a dB of peak gain advantage to the classic 4-square. But the difference is in the takeoff angles. The 4-square has a peak gain around 24 degrees, and the Moxon with the half-wave radiator 15. So we're looking at 9 degrees roughly of decrease in the takeoff angle, which would be desirable for working those long DX paths. Now let's look at the pattern in the azimuth plane, and we know the 4-square does a very nice job in firing in 4 different directions, covering all of the compass angles. And you can see here's the blue trace again is the 4-square. Notice peak gain is higher, and in the back it has a lower front to back ratio. These 2 traces were not made at the same takeoff angle. They were each made at the takeoff angle where the particular antenna had the most gain. So this blue trace for the 4-square, that's at roughly 24 degrees takeoff angle. The red trace for the Moxon tall Yagi is at just over 15 degrees. So there's a lot of similarities between the performance of these 2 arrays. One of them, of course, is parasitic. You have a driven element in the center. You just run your feed line to the tower in the middle, and then you switch the parasitic elements from either reflector to director using relays. So in one sense, the Moxon-Yagi, the parasitic antenna, is somewhat simpler in terms of feeding. For the 4-square, you need to drive power into all 4 elements, and you need a phase box of some kind to do that. So as usual, I tell my kids there ain't no such thing as a free lunch. There's strengths and weaknesses to every kind of electrical engineering project that you have. No single antenna does everything best. Now here's a drawing that Joe made showing what you might want to do if you wanted to cover all 4 directions. So notice he's drawn, instead of 2 parasitic elements, he actually has, he's added 2 more parasitic elements, showing relays to switch them from reflector to director. Now I went ahead and with the computer, the EasyNet software program, I decided to see what could be done. And the idea here is this is the bottom bent leg of the parasitic element. Notice I've got 1, 2, 3, 4 relays in here. And the idea is for maximum utility on this array, we would like to be able to use it on CW and phone as a directional antenna. So this wire should be able to be a reflector on CW, or a director on CW, or a reflector on sideband, or a director on sideband, or the fifth option is if we open all 4 of these relays, then in effect we have detuned the wire element. We've made it electrically invisible, and if we detune all 4 of the wire elements, then the antenna becomes an omnidirectional antenna. So, for instance, if we want to beam to the northeast, the front element, the northeast element, let's say we're on phone, would need to be a phone director. The southwest element, the one in the back, would need to be a phone reflector. And then the other 2 elements that are on the northwest and the southeast, they would need to be detuned so that they're not in the circuit electrically. So we'd have 2 elements that are active, and then the other 2 elements that are on either side would be inactive. They would be detuned. So that would be in the detuned setting, we can open all 4 of these relays, which would just chop this wire up into pieces. I suspect that it might be simpler if we just disconnect, we just opened K1, it would probably work fine. Notice for SSB director, that's the shortest piece, so we would close K1, and then these 3 would be open, so then this wire, and this wire would be inactive. For an SSB reflector, we close this one and this one, so now this 23 feet is connected to the rest of the wire, and these 2 pieces are disconnected. The next would be for a director on CW. Now I need to close this one and this one and this one. So 15 plus 8 plus 3, 26 feet of the wire is active. This piece is disconnected. And then last of all, when I close all 4 of them, this entire length of wire is active. It's in the circuit connected to the rest of the element, and that would be for operation as a CW reflector. So, very interesting antenna system. As I mentioned, Joe only used it in the northeast and southwest orientations. He didn't have 4 parasitic elements, he had 2, and he always used it either firing northeast or southwest, so he did not have the option of detuning them. So he wasn't really interested in an omnidirectional operation. So that's the gist of my talk this evening. As I said, I thought maybe there'd be some questions that only Joe could answer. I know that it worked very well. It's helped him to top the 300 mark on 75 meter phone, and very cool antenna. I had a lot of fun working with him on that. Any questions or comments that you might have for me?
Just one, Al. So you're using the NEC4?
Yes.
Okay. Do you find that putting the radials in, because I've got NEC, I just use the NEC2, I've got EasyNIC Plus, but not the Pro.
Mm-hmm.
Do you find it makes a big difference in the modeling with the ground?
Not really. I'm guessing that you use the mini neck style ground.
Yeah.
That really works pretty well, Corey. It runs a lot faster. It tends to give results that are a little bit optimistic. In order to get the gain that mini neck predicts, you typically would need to have a really good ground screen with a lot of radials. But from my perspective, mini neck works very well. Using the mini neck style ground, I like a lot. It's really pretty good. And of course, if you're making relative comparisons and you use the mini neck style ground for all of your models, then the absolute numbers are probably not exactly right, but the relative differences are pretty valid.
I'm finding that in a lot of measuring type of things, your
Yes.
absolute versus your comparison. So compare apples to apples and you're good, but you start bringing oranges in, it's a problem. I was just wondering if it was worth the investment. I mean, I like modeling and I really enjoy it. And I figured, is it something that was worth it? But from the sounds of it, for what I needed to get out of it, I think what we've got works.
Well, Corey, I've got a question for you. Can you now actually buy a NEC 4 engine for EasyNEC? Is that something that you can buy?
Yes, they've got. I just looked. So NEC 5 is out, but they still offer NEC 4. It looks like, from what I can see.
Okay. The reason for my question was years ago when I started in this, the capability of modeling buried radials. The NEC 4 technology was classified as military critical, and you couldn't get a hold of it unless you had like approval from a particular government agency. So if I'm understanding you correctly, now a person can get a hold of that themselves without having to have that approval.
I think you have to. There is a thing about export. You can't export it. You have to, the license agreement says you have to be US and you can't export. But yeah, there is some stuff in there for that.
Okay, very cool. Any other comments or questions?
Other questions for Dr. Crissman, K3LC.
Could you talk a little bit about the Mylan, Tim? You hear me? No?
I'm sorry, I missed the last part, Alex.
Oh, okay. You can hear me? All right. Yeah. Could you talk a little bit about the difference between the CW reflector and the phone reflector? I'm not sure I understand that.
Okay. Let me scroll back down here to the drawing. If you want to operate on CW, typically the DX phone band is up around 3795, but the DX CW band is closer to like 3505, 3510. So the frequency of the antenna then has to be, the resonant frequency has to be made a lot lower to operate on CW, which basically means this wire, this part of the wire that's active has to be longer. So if I want to operate on CW as when I want the wire to be a reflector, I have to close all of those relays.
Okay.
So that all of this wire here is in the circuit. If I want it to be a CW director, it can be a little bit shorter. So I open this relay, excuse me, and then I have these three segments are in the circuit, which moves the resonant frequency up. And then, of course, for a phone reflector, I have to remove both of these pieces, and then the reflector uses this 23 feet, and for a phone director, it's even shorter, and I open all three of these, and we just use the 15 feet.
Okay. Okay, thank you.
You're welcome. And to me, it's really kind of cool because all of the switching, all the relays are down here at the bottom where they're fairly easy. All you have to do, run some wires from here down to the ground level, which isn't too far. So it's a lot more convenient to have all the switching done down here relatively close to the ground.
So one question that always comes up when people use towers as driven elements, how does he insulate the base?
That's a good question. My memory tells me that he had a ceramic insulator that I believe, it was a piece of, the pointy end of the Roan tower, instead of having the straight section, you have a pointy section. We put the pointy end down, and then I believe he had a surplus ceramic insulator at the base. And if you don't have that, then you can use a regular straight section, but then you'd have to have 3 insulator, and you can make them if you're a good machinist. And I think Tim, what is it, Delrin, that you make insulators out of sometimes?
Yeah, we've done that here, Al. I think on a project you worked on with me, we used Delrin, and but I'm currently using an old surplus, and they are around even at a good price. Ceramic broadcast insulator, Al.
Cool.
You know, so it, but Delrin can be machined pretty easily, Al, and you know, to make so that you can insulate a tower.
Excellent. Thanks, Tim. Okay, if there aren't any more questions, I thank you for your interest, and thank you, Tim, for inviting me. And it's nice to be able to look out the window here and still see that it's not dark outside yet.
Well, you know, it's great to have you give a presentation right from your office there at Grove City College. And Al, how many years have you been teaching there?
Well, this is the end of 33 in about 6 more days.
33 years of teaching, and that's so incredible, and your dedication to not only Grove City College, but how many articles do you think you've written for amateur radio periodicals?
It's somewhere around 60, a little over 6, I think. In the last couple of years, I've had some medical challenges, so I've been much less active, but I think all the medical issues are in the past now. Everything is working the way it's supposed to.
That's great. And how many countries do you have on 20 meters, Al?
Well, I still need North Korea.
Don't we all? That's great, but you have everything else, right?
As far as I know, it's, you know, sometimes they create new countries that weren't there before, but I believe I have all but one.
That is great. And Al, you might just comment on some of the emails that you get from all over the world asking questions on articles that you've produced. I can imagine you know, through the magic of the internet, guys find you and maybe ask you questions about an article. I know you and I co-wrote an article back in the early 90s, which is coming up 30 years ago. And I still get questions about that. And I imagine you do too.
Yes, I was just, the K3LC sloper system for 160 meters. That is a popular one. And I think Luke Rumbaugh just had a group of our kids from his communications class come to visit. And so I actually sent him a copy of that article. He said the students were interested in the idea of having an antenna that didn't move physically, but you could magically switch the radiation pattern from one direction to another. So
yeah, we should have opened the relay box, but you know, Al, as you know, the real secret to a tour of having young kids here that are soon to be graduates of Grove City College is to have a ringer. And I had a ringer. Corey came out, and Corey is 20 years younger than I am and a Grove City EE grad. So that made the difference.
good job, Corey.
See how, you know, here you go. 20 years ago, you were Corey's advisor. I'm getting all teary-eyed here, and it worked out really well.
Yeah.
I still remember the first day of my EMAG 2 class, sitting down, you come walking in, one other person, Bob Duke, comes walking in. It's like, well, now that you're both here, it's like, oh.
I remembered having a class with 3 students, but apparently it was just 2. Wow.
You talk about one-on-one.
You don't get that at bigger schools. So
No, that is so great. And we do have some other folks from Grove City College on here tonight too. Dave, K3KDR. It's also a Grove City guy, and I don't see Josh on with us at the moment, but Dave, had you run into Dr. Crissman when you were at Grove City? Need your audio, Dave.
I was never a student at Grove City College, so I wouldn't have run across him.
For some reason, I thought you attended.
Josh was a student at Grove City College for a little while. But no,
Okay.
no, I never was. You just have mixed us together a little.
Well,
we've done everything together, but not attend Grove City College.
Okay, great. I'm sorry for that. But
all right.
It's great to have you on to hear Dr. Crissman here tonight. Any other questions for Al, K3LC?
Yeah, you can call me Al. I think there was a song about that.
Al, thanks so much for presenting to us tonight. And, you know, for a long time, we had a yearly tradition of having you present to the Mercer County Amateur Radio Club, and I want to bring that back. I know you do a lot of research on a lot of different antenna topics, so I hope you will come back next spring. And thank you for all you do, and thank you for your dedication to Grove City College and to sharing your expertise with the amateur radio fraternity. Well,
let me say thanks to you. Thank you for inviting me, and also thank you for all the work you do in encouraging young people, including our students. That is one thing for them to sit in a room and hear some guy with a beard stand up front and lecture and write on the board, but it's another thing for me as a practical guy. It's another thing to go out in the field and see the stuff, you know, and be able to put your hand on it and look at it and realize with your mind, you know, how big it is and how cool it is and what awesome things you can do with chunks of metal. So thank you. God bless you.
Yeah, thank you, Al. And I was very quick to point out the matching network that you designed for the 3-element parasitic vertical Yagi here on 160 meters that takes us from 25 ohms up to 50 ohms. And it's been doing that for over 20 years. And gosh, 160 meters works so well here. And thank you so much for that. Any last questions for Al Crissman, K3LC?
Al, anytime you want a VE session for your students, let us know.
Okay, thank you for offering. I'm actually involved with some people from my church right now who are interested in the possibility of getting technician class licenses. They're kind of thinking about emergency communications and maybe the option of using 2-meter repeaters in case push comes to shove. And so I know there's some mature individuals from a number of the churches that are interested in getting licensed at the technician level. So